one term. And they classify that as, even though the word poly may throw you off, they also mention that will fall into this group of functions here. Does anyone recall what the function was that had only one term?
Linear.
That's about
I'm
or no. And then I'll pick up, as I've heard my students give me, a binomial and trinomial. Those are the basic ones that you've seen before. Aiden, could I have four terms?
Yeah.
Yeah, and they have a particular vocabulary word for four. 5, 6, 7, could I have one that goes forever? Yes. Okay, but I'm looking for tonight with this in chapter 3 to be finite. In other words, we're going to end. We just have so many terms. I think the highest I go to, guys, in all my discussion in chapter 3 may be up to 8 terms. I usually go up to 8, and I could go further. Okay, monomial, 1 term, binomial, 2 terms, trinomial, 3 terms. You say, Professor, I've sort of forgotten what's that mean? Monomial, if I say 4, that's considered a monomial. If I say 4x, monomial. If I say this, 4, x squared, y to the 4th, c cubed, monomial. Binomial, I need 2 separate terms here. Binomial, 2x plus 4. That's a binomial. Or x squared, subtract 3x. Binomial. Trinomial, 3 terms. Easily done. X squared plus 2x minus 8. That's 3 separate terms. Then we go further, 4 terms, 5 terms, 6 terms. You know what's going to happen in chapter 3. I think you sort of get a sense of what's going to happen. They're going to ask you to find the zeros of these functions. If it's this, start this one, you have no problem. X squared plus 2x minus 8, I could, and I'm standing here and I made it up real quickly. Does that factor? I can actually factor it and find the 2 zeros for it. In fact, it's quadratic. So that falls right in line with what we've been doing. But what chapter 3 does is it says, let's open it up though. Have students now to look at this. I got some crazy here. 1, 2, 3, 4, 5. I made this one have 5 terms. That's a polynomial function. Now, if you want to know the particular term they use, like binomial, trinomial, what type of nomial professor is it, they may give you, if you check, do your research, they may give you a name for it, but it has 5 terms. What are they going to do, guys, eventually, do you think, on something like that? What do you think in chapter 3, coming up shortly, are they going to ask us to do with a polynomial function? Where you as a student are hoping, Professor, please, keep it quadratic. Don't go up to a 4, Professor. And for goodness sakes, don't go up to an 8. What do you think they're going to ask you eventually to do?
Find the x value.
Find the x values. Solve it. They describe it as find the zeros. And so if I see 4 here, at least I got to find 4 zeros. That can be crazy. Wait till you see if I get a chance tonight. I may not get a chance to get to one I just looked at earlier to show you that we were actually going to get all the answers. But this one right here would be jump into it and try to get the 4 zeros. So we're actually find the zeros of these polynomial functions. With that said, and a little description, you guys, let me see. Aiden, I've been calling you a lot. You don't mind, do you? Can you describe for us, look at the bottom there, how do they describe a polynomial function? What form, as I start out with, what as the first term?
A, n.
A raised to the n?
No, I don't even know how to read this thing.
A subscript n.
Right.
X raised to the then plus
A to the
subscript n minus one,
n,
x raised to the what?
n minus 1.
N minus one. Write another one, may not be on the handout. Subscript n minus two, x raised to the n minus two, I see a pattern here. And then it keeps going. Aiden, did I say near the end, maybe you have a term with
Yeah.
just an x, a1x,
Yeah, a1x plus
and then what's on the end?
a0.
A subscript 0. Now you open up any math textbook, go on to Berkeley, no particular math textbook. They're going to describe a polynomial function like that. Are they going to say, oh, you saw this back in middle school? Ramsey said you saw it back in middle school. It's binomial, trinomial, monomial. No. They're going to show you what it looks like written like that. And then they're going to go jump into it and start working with it. They may not reference binomial, monomial, trinomial. But in general, they all take this shape. Look at the shape here. Now, I don't think on the handout I gave any words, vocabulary associated with this. Don't do it now. Guys, the x raised to the n is known as the degree. I think I've used that word degree in here before. The a subscript n that he gave me, this is my leading coefficient. My first coefficient. I have a leading coefficient, a degree. Now, can someone tell me, based on what Aiden gave me, is there something you describe for me as you take a look at the first term to the second to the third, and it falls down to this, and then finally on the end? Can you tell me something going on that you did see back in middle school, why they may have written it like this? In other words, they start out with x raised to the n, then all of a sudden they jump into x raised to the n minus 1, then x raised to the n minus 2. My next one would have an x raised to the n minus 3, x raised to the n minus 4, as many of those terms that you need. Does anyone remember anything in middle school that would be associated with that? Why would they do that? Something that maybe the teacher mentioned, but they didn't mention it like this. I'm trying to make a reference back to middle school. Why might that be true? Yes?
Does this have something to do with sum notation?
Not quite.
Okay.
It has something to do with something that maybe you're not thinking of, but basically you saw it and know how to do it. Every student in this classroom knows how to do it. It's something that a middle school teacher probably insisted you do when you write these polynomial functions, and that may give me a rationale why that thing's written like that. That's why I hang going up. Yes, Lisa?
I'm thinking this relates to the exponents.
It does. These are exponents. Hang on. So I got an exponent, another exponent, another exponent. So those are exponents. And also, Aiden says I have little subscripts just to represent which term I'm in. But I'm looking at those exponents. So tell me, on the side here before you answer.
Could we also be related to the rational function?
Not yet. Okay, on the side here, guys, right quickly. If that middle school teacher, and I'll get back to this, had you, look at this. We got doubt back then they did something like this, but who knows? It looks like that. That's a polynomial function. Degree, in my case, degree is 4. Leading coefficient, what's my first coefficient? 3. So I've got a leading coefficient of 3, degree is 4. Now what did they sort of insist that you do when they did these back then and you placed an answer? Now, something that usually most teachers insist you do when you write the answer. Did you want to recall? I got 4 to start out with, that's my degree, that's the highest. Then jumps down to a 3, then jumps down to a 2 for the exponent. Then down to what, a 1? And then I have a constant on the end, no x. What was that teacher asking you to do? Who remembers? They asked you to put in something.
Well, I mean, you're organizing the.
There's no order. There's no order to it.
Yeah.
Does anyone remember the order that most teachers ask you to put the answer in after you did a polynomial function problem? They usually ask you to place it in some order. In other words, I'll give you a hint. And I'll get back to where it should be. They would not accept this. Why would they say no? Many teachers in middle school should count, so we'll take a half a point off or a point off if a student did that. Why is that not acceptable? There you go.
Because it's not in the order.
That, what order did they usually ask you to place your polynomials in?
From the greatest to the smallest.
Let's start with the greatest and drop down to the lowest. It's in descending order. If it's not in descending order, they usually took a point off. So is my first one right here, is that in descending order? From 4 drops down to a 3. 3 drops down to a 2. 2 drops down to a 1. That's in perfect order. Your teacher would love you. You do this. They say, wait now. You start with 4, then you jump down to a 2. No, you jump from the next one to 4 down to the next one to 3 to a 2. You make it in descending order and make it some order to it. Don't put all those terms all mixed up. They call that descending order. That's what this is, Aiden. If I start with an n, I would expect the next one to be n minus 1 in general. Next, n minus 2. Next, n minus 3 if I want some order to it, called descending. And finally reach the end where there is no x at all, and they identify this as your constant in that polynomial function. Guys, descending order, leading coefficient, degree, a constant. It's crazy. Now, I know I get carried away with this. I could be here until 9 o'clock tonight. Would not bother me a bit. It'd bother you, though. Wouldn't it be nice to stay here till 9 o'clock? Yeah. Oh, your head shaking, oh, professor, not 9 o'clock. Yeah, I'd love that. Here it is in descending order, constant, leading coefficient, degree. What do you think that degree tells me later on, shortly, about my polynomial function that we've expressed in here before? What do you think the highest exponent called the degree tells me?
Will show how the graph will behave.
Something like that, something else.
How many zeros?
Thank you. Aiden, say it again.
How many answers?
How many answers, or they call them zeros? How many zeros will that polynomial function have? You better look at the degree. The highest exponent says you have these, and you gotta find them. Now that's gonna be a problem. That's gonna be a big problem. When they ask you to solve one of these crazy things, which I may not get into tonight, and you've gotta find 5 answers, or 5 zeros, or 6 zeros. And some of them may be imaginary of those. Okay, so that's what's going on here, guys. Now, with all that said, let me erase this. Your textbook, now I may mix this up a little bit myself though. I didn't quite like the order the author did this, but I'm gonna do it. Part 2, they would like us to first get this out of the way. Sketch one of these polynomial functions. Sketch one. Now I'm going to mention a few that we should be accustomed to and may not fully sketch it. I'm going to form maybe my first one like this. Let's call it P of X. Let's do a binomial. That's a polynomial function. Except it's given a special name, binomial. It's a binomial function. I'm not going to graph it for you. What would that graph into? A parabola vertically shifted down? 4. Is that true? That was easily done, but it's an example. That's a polynomial function, binomial function. And it's a parabola vertically shifted down 4, and you're done. If I saw this, and let's see if I'm ready for the ones I have here that I brought in. Look at. Hang on, see if I have it here. I do. If I saw this, that's a trinomial, which is a polynomial. Could you graph that one? what x squared subtract x subtract 6 graph into? Parabola. It's a quadratic. I made these two quadratic. Quadratic. Now what might you do though, which is going to be on the quiz Wednesday, what might you have to do if I intend to graph that quadratic? Go for it.
Factor it to find the zeros.
Now you can find the zeros, tell me more.
Or put it in a vertex form.
Or you could put it in that vertex form. You could do as I open up class tonight with. You could put it in vertex form, complete the square on it, and then graph it. And that would be the graph of that trinomial. Okay guys, we can do that. Number 3. Now, watch my time here because I have another handout to give you guys. The next one looks like this. Hang on guys, they're calling by my car here. Sorry about that. The car's in the shop. Okay, here we go. P of x is equal to, now it looks like this. X cubed, subtract 4x squared, subtract x, plus 4. Now that's where I want to get to tonight. Wow, wow, wow. I hope I copied it down correctly. Whew. What a class tonight on a Monday. Parabola, first we shift it down forward. I could factor this, and our students suggest I get what, maybe critical points? Use sign analysis. Is that true, guys? I heard that. Would this guaranteed to be a parabola if I did all that? It does. It's a parabola. This one says x cubed. And next should be x to the 4th. And finally, I see on my paper here an x to the 8th. They want a sketch of these polynomial functions. Now, can anyone give me a suggestion on this one? What's my time here? To get a start on what on earth does this look like? It's not a parabola. These two are parabolas. It's not a parabola. It might resemble something, but it's not a parabola. So can anyone give me a start? I hope you tell me some good things here so I can get this done. To get a nice little sketch of x cubed, subtract 4x squared, subtract x plus 4, that polynomial function. Go for it.
You group them?
Group. Let's group first. Suggestion was do this. Let's see what's going to help. He wants me to group the first two and the last two. Now what did you want me to do in the first grouping? X cubed minus 4x squared.
Factor out x squared.
Take out x squared and you're going to have what? X subtract 4. What might you suggest I do in my last grouping?
Factor out -1.
Factor out -1, this guy's on it. I would call it negative. Grouping. Now, is the factoring done? I love the grouping part. Is the factoring complete? No. Did he now create a common factor in both those terms? An x minus 4, so I can take that out. And can anyone tell me what's left over if you pull out x minus 4 with his help? What's left over?
Should be x squared minus 1.
Love it. Hang on. Love it.
We can then also simplify.
Now, x squared minus 1 can be simplified further. It's a difference of squares. And you can say, wait, Professor, you can do more with it. Now, I have rewritten that green function into the orange. I guarantee you, if I walk up to Mr. Park with all the math he knows, and I see him out on campus, and he knows me by now, if I see you on campus, oh, you guys have been avoiding me. I walk across campus, I don't see you. Even if I see you, I've got a math question for you. Right, Mr. Park? If I see Mr. Parker, I'm gonna have a math question for him. He avoids me also. May say hi and wave at me, and then he's gone. No, he didn't want a math question, but if I see you on campus, I might ask you a math question. This orange is equivalent. These two are the same, but written in different forms. Why would I want to rewrite that green? What is the benefit of doing what my student helped me out with, my students, and put in the orange? What's the benefit of the orange?
You get to see the zeros.
You get to find the zeros quickly. Thank you. Here we go. To find the zeros, split these up, the factors, and set each one equal to 0. This class needs to be recorded. It is being recorded, of course, but it needs to be shared with other classes. Because I'm hearing some things going on. This is 4. This is -1. This is 1. Those are my zeros of that polynomial function. Lisa? But what they want us to do before I close down tonight is don't stop there. That's beautiful. They want to see a sketch of that. And I know it's not a parabola. It's some type of a cubic. Now what would you suggest? Lisa, any suggestion of what could I do from there?
Could you look like piecewise,
Tell me again.
piecewise function, the piecewise function?
Oh, not piecewise. Oh, let's not go there. Something else that we've done in this class, and I've done all this work to lead up to this.
Maybe I think first maybe trying to put the zeros into the original equation.
Okay, hang on. No, something else. You mean for a check? You could actually check it, yes. But something else I might, or we've done in this class.
Sign analysis.
Thank you. Wait, Professor. Can I go use a sign analysis with my zeros, and I have 4, -1, and a +1. Guys, let me list those like this, and -1, 1, and a 4. Make sure all of those are listed correctly. Now, those are my critical numbers. And I'm going to apply sign analysis for some reason. All this math should relate. How someone could teach math and I have one topic not relate to another topic, not relate to it. That's not math. Math is all connected. It's all connected. We're back to sign analysis. Now, what should I do now? What did sign analysis ask us to do back when we did sign analysis? We test. And guys, when we test, we're going to test something here, and I'm going to be very patient. Something here, make sure I have everything arranged in order. So far, so good?
Mm-hmm.
Okay, to the left of -1, you know how it works. You get to try anything you wish. In between, anything you wish. Between 1 and 4, I'll try 3. Out to the right, I'm trying 10. Those are my test points. Now you know how it works. -2, take them back right here. Replace x by -2. -2 minus 4 is a -6. That's a negative. -2 plus 1, negative. Make all this relate. -2 minus 1 is another negative. Don't let me mess up here with all my signs. And I think all that together is what, negative?
Negative.
Now in between, I'm trying 0. 0 minus 4, negative. 0 plus 1, positive. 0 minus 1 is another negative. I think all together is that positive. I'm trying 3. 3 minus 4 is negative. 3 plus 1 is positive. 3 minus 1 is positive.
Negative.
That's negative altogether. Trying 10, my goodness. 10 minus 4, positive. Guys, is it positive all the way across?
Yeah.
So therefore, it's positive. Sign analysis. Now, you say, Professor, that tells me something going on with these signs. Now, can anyone tell me out to the left of -1, we found this region to be negative. What does that tell me about the graph itself?
If it goes.
It's
down.
gotta be below the x-axis, which is this axis. It's gotta be below. So if I want a rough sketch, and I'm gonna make a curve here, it's not straight lines for this curve or graph. Guys, I wanna just do something like this, it's supposed to be below, so it might look something like that.
How do you know what you're looking for?
What's that?
How do you know what you're looking for?
What do you mean?
Because it's not greater than 0, less than 0.
Oh, beautiful, beautiful. He's thinking, I love this. He's a white professor. He's good. He's a professor. That's what we did when we did stuff like that. Right? And then we found the regions that was positive in this case. And then we shaded in and then wrote that in interval notation. Now we've opened up tonight a new chapter altogether. We're saying now, no, we're not going to do that. We're going to just look, and that's going to tell me whether it's going to be above or below. Positive, above, negative, below. So this, since it came out to be a negative, let's see exactly what you're thinking. This says this piece of my graph, whatever it looks like, it's going to be below. That's what negative means, below the axis. Here, it came out to be what? Positive, which means now it's going to go what? Above. How far above it goes, I don't know, you don't know. I doubt Mr. Park knows. It's going to go up, and eventually it's going to turn and come down and pick up the other point. Is it true? By the way, have I formed quickly a local maximum doing this? Yes. Now, Mr. Park probably could find it for us if I asked him to do it by using calculus. But right now, I don't know, unless I use a calc technique. There is a high point right here somewhere. There's a local max in here somewhere. I don't know where it is, just makes a shape. Next region came out to be what, negative?
Negative.
Oh my goodness, that means it drops below. How far down below it drops, I don't know, you don't know. It's gotta come back up. In reality, it may drop way down, come back up. I don't know, but just make a shape. And, oh, by the way, have I now discovered another, maybe a local min? I had a local max. Now, is there a local min in there? Yes, where it is, I don't know. To do calculus. And finally, on the end, it can be positive, which means what? It goes back above, like that. Now I'm stepping back. Oh, that's not bad. I'm good. That's a good shape. I bet if I asked Mr. Park to sketch it right here, I bet that's his sketch and my sketch with a program of some sort. I bet we're very close to the same graph. Could you sketch that real quick for me? Let me know if it looks at least something like I have on the board. Then I'll continue my conversation. Yeah.
What happens if you're given a function that skips terms? So like, for
Oh,
example,
beautiful.
you
Beautiful
have
question. There's a
x
term
y
missing.
x.
You're going to put a placeholder, they call it placeholder. A placeholder in. I'll show you one of those later. Ah, beautiful. Sometimes those terms are missing.